Let's work on a couple problems on the ideal gas law. So the first one here, what is the pressure exerted by 0.508 moles of oxygen in 15.0 liters container at 303 Kelvin? All right, so for this one, our equation for any kind of ideal gas problem is PV is equal to nRT. Okay, and the question is, what is the pressure exerted? So we are being asked for the pressure, so which means P and then nRT over volume. That's going to be our equation, cross multiplication, right? And then we go ahead and plug in all the numbers. Make sure that all your units are in order, which, let's see if they are, moles for oxygen, and R of course is going to be the liters atmosphere, Kelvin mole. Our temperature is in Kelvin and our volume is in liters. So we are all set. So go ahead and plug in all the numbers. 508 moles times R, which is 0.0821 liters atmospheres mole Kelvin. And then the temperature is 303 Kelvin and the volume is 15.0 liters. Okay, and go ahead and cross out the units: liters, Kelvin, mole, and you're left with atmospheres. Okay, which is what we are calculating for: 0.842 atmosphere. Okay, that would be the final answer for this calculation. So pretty easy to do, so long you have all the numbers. So here, let's take another example now. And in this case, we have what is the volume occupied by 16 grams of ethane gas, which is C2H6, at 720 torr and 18 degrees Celsius. Okay, so now again, our equation is going to be PV is equal to nRT. That does not change because it is not a set of conditions, initial or final. So in that case, we have to use the PV is equal to nRT. But now we need to work on our units a little bit. Okay, so for example, for pressure, we will need to convert 720 torr to atmosphere, because remember, R is in atmospheres. Okay, so we need to get to atmospheres. So now for the conversion factor, 1 atmosphere had 760 torr, and that is equal to 0.947 atmosphere. That's pressure. Volume is what we are calculating for. N is number of moles, and so we will convert 16.0 grams of C2H6, which is ethane, to moles, and grams of C2H6, moles of C2H6. So that is in 1 mole we have 30.07 grams, and again that is from the periodic table, right? 2 carbons and 6 hydrogens. And this is equal to 0.532 moles. Okay, and then R is the gas constant, and then temperature, of course, we have to convert now from 18 degrees Celsius to Kelvin to 73, and this is equal to 291 Kelvin. Okay, and now we'll go ahead and set up for our volume, which volume is nRT divided by P. So here we are. N is our moles, 0.532 moles. R is 0.0821 liters atmosphere per mole Kelvin, and then the temperature is 291 Kelvin divided by the pressure, and the pressure we calculated is 0.947 atmosphere. Okay, again cross out the units, atmosphere, and then Kelvin. We're left with liters. Okay, that's what we're calculating, and then the final answer for this one will be 13.4 liters. So the problem is not hard. Again, it's just PV is equal to nRT. The only thing different here was that you had to make sure that all your units were in correct order. Okay, so simple problems.